Welcome students, this is chapter 13, One-Way Analysis of Variance, also known as ANOVA. So the objectives for this chapter are to know when to use an ANOVA test, to know the 5 steps of hypothesis testing for ANOVA, how to calculate the F-test statistic in eta squared, which is your effect size, and then also how to interpret SPSS output for ANOVA and post-hoc analyses. So this chapter is filled with formulas galore, as we can see. All these different formulas. But the nice thing is, as much as there's all sorts of different formulas, these are the ones that you're really going to be using. And again, I'll be giving you these formulas on your formulas page whenever you have an exam. So what is ANOVA? Well, again, it's an acronym for One-Way Analysis of Variance, and really ANOVA is analysis, A-N-O, variance, V-A, ANOVA. And what this test is a statistical procedure that can compare 3 or more groups on some quantitative variable. So that variable, that dependent variable, we can calculate a mean and standard deviation for. Hence quantitative, interval, and ratio. And then if you have an ordinal variable, when you have at least 5 groups that makes sense to interpret a mean and standard deviation for, you can then use that as your dependent variable. And really, ANOVA is also known as an F-test or an F-ratio. And in this test, we have an IV and a DV, obviously, where the IV is the variable specifying your groups. So for example, what county do you live in? And your dependent variable can be whatever it is you expect to vary between 2 groups. This is your outcome, your quantitative variable. So for example, average number of miles driven annually. So whenever you're working with ANOVA, you should see 2 variables, one that's categorical and one that is quantitative. The one that's categorical is always going to be your IV because that's going to give you your groups. And the one that's quantitative, the one that's numerical, is going to be your dependent variable. So let's take a look at this example. Let's say I had 15 people and I had 5 people from each county, LA County, Orange County, and San Bernardino County. And for each of those 5 people, giving me a total of 15 people in my sample, I asked each of them how much they drove in the last year. And we can see here 18,000, 15,000, 20,000, 10,000, 12,000 for LA, 23,000, 10,000, 25,000, 30,000, 27,000 for Orange County, and so on and so forth for the 5 people from San Bernardino. And so with that, we can obviously calculate a mean and a standard deviation. So here we have the means for each of our 3 counties, our 3 groups. And really when we think about this, we can think about differences between groups, which is really the differences between LA County, Orange County, and San Bernardino County. And this is really what it is that we're testing. Is there a difference between these 3 groups on the number of miles driven? And really we want to see, okay, if you live in Orange County, do you drive much more or much less than people from San Bernardino or from LA? Is there a significant difference between these groups? And this is the systematic influence that we're trying to look at. Trying to see if location has a systematic influence, has an effect on how many miles somebody drives. So this is looking at variances between groups. And this is what we denote as SSB, also known as sum of squares between groups. But we also have variances within our groups, also denoted as SSW, sum of squares within. And the variability that we see within the groups is simply the variances, the differences observed within each of those own groups. So of the 5 drivers in LA County, what is the variability among those 5 people? What's the variability between the 5 people from Orange County? What's the variance between the 5 people from San Bernardino County? This is the variance within groups. This is also known as our unexplained or residual errors, or residual variance. And so when you think about this, when we talk about low variance, when we talk about ANOVA, would you think that this is people between or within groups that have very similar scores or less similar scores? And conversely, if we're talking about high variance within our ANOVA, if we had high variability, the people within our groups or between our groups have, what do you think, very similar scores or less similar scores? Go ahead and pause this video and think it over for a second and see if you can figure out what the answer is. So when we're talking about low variances, this is when we see that people within groups or between groups have very similar scores. Right? If the 5 people in our group, if the participants within our sample have very similar scores, then there's going to be very low variability. They're going to look the same. So we're going to expect that there isn't going to be much variability within the group, so there's going to be low variance. Conversely, if we have high variances, well, the people between our groups or within the groups have less similar scores. That if they look different, the more different there is, the more variability, the higher the variance is. So let's take a look at this first question here. Does this data have high between group variances or high within group variances? Pause the video, think it over, and then play the video when you think you've got your answer. So let's take a look at each of our 3 groups. We see that the 5 participants in LA all have the same mileage, all 10,000 miles. The 5 folks from Orange County all drove 20,000 miles, and all the 5 folks from San Bernardino County all drove 30,000 miles. So given that, within the groups, they all look the same. But between the groups, the differences between the 3 different counties, we see that there is differences. So we have high between group variances, and actually no within group variances, because all 5 people from each of the 3 groups have exactly the same mileage. So what about this question here? Question number 2. Does this data have high between group variances or high within group variances? Pause the video, think it over, and then play the video again to see if you got the right answer. Okay, so looking at the 5 people from LA, we see one person drove 50,000 miles, another person drove 5,000 miles, another person drove 35,000 miles, another person drove 10,000 miles, and another person drove 20,000 miles. And we see that the mean for LA was 24. The mean for Orange County folks was also 24, and the mean for San Bernardino folks were also 24. So we see that between the 3 groups, they all have the same average, 24,000 miles. But if you look within the groups, we see that there is differences. The 5 people from LA drove all different mileage. Same thing for Orange County and San Bernardino County. So given this, we have high within group variances and actually no between group variances because all 3 means between the 3 groups are exactly the same. They're equal. Okay, so go ahead and head on to part 2 of chapter 13 to review the 5 steps of hypothesis testing for F-tests or ANOVA.